Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to be talking about solubility rules. And this lesson ends up being a preview to the next video, which is going to be on net ionic equations. So you kind of have to know your solubility rules in order to be able to do net ionic equations. And it really comes down to deciding if an ionic compound is going to be soluble in water or insoluble in water. So what we have is like each teacher is going to give out their students a list of solubility rules. And we're just going to use the solubility rules that we have in our textbook. What I do for my students is I give them flashcards. So if you want to take a screenshot here and then use these as flashcards, that's always a great idea when you're learning your solubility rules. Now there's some of these rules that are kind of more important than others, and I'm going to put those on the board, okay? The first rule that's really important is the things that are always soluble. Now, I typically call these things trump cards. So if a compound has nitrate in it, it's always going to be soluble, no matter what you pair it with. The same thing is going to be true for acetates. So nitrates, acetates, if there's ammonium in the problem, and then lastly, any type of alkali metal ion, okay? So we're talking about lithium and sodium, potassium, rubidium, and cesium. If any of those things are in the compound, it's going to be soluble, which means it's going to dissolve in water. So I kind of call this group kind of like the trump cards. And you could actually get really, really far in chemistry with just knowing this one solubility rule, okay? Now, some other things that are typically soluble in water, but there's exceptions, are going to be things like chlorides, bromides, and iodides. Those things tend to be soluble with a couple exceptions, okay? And then according to the textbook here, our insolubles are going to be sulfides, carbonates, phosphates, carbonates a 2 minus, okay, and hydroxides. Okay, so these are going to be kind of our insolubles. However, these guys, they do have exceptions, okay? And the exceptions are kind of the things that you got to end up memorizing, okay? Same thing for here. There are exceptions. Once again, if you want to see those exceptions, they're listed right here, okay? So what I'm going to do is I'm just going to give you a couple compounds, okay? And then you're going to decide if they're soluble in water or not, okay? And the first compound that I'm going to give you is going to be a sodium carbonate. So a lot of times we tend to look at that negative ion. We see carbonates. Carbonates are typically insoluble, but there are some exceptions. I wonder what those exceptions are. I wonder if sodium is one of those exceptions. But if we come over here and we look at our trump card, sodium falls into this category of alkali metals, okay? And if you have this trump card, okay, no matter what you pair it with, it's going to be soluble. So since there's sodium in here and it's one of the alkali metals, we're going to say that this is soluble, okay? Now, what does that mean as far as a net ionic equation? As a net ionic equation, we would end up splitting this up. So if I did a particulate diagram of this, I would have 2 sodium ions, 1, 2, for every 1 carbonate ion. This would not be a molecule of sodium carbonate. It would be split up into its individual ions because it's soluble in water, okay? Let's do another one, okay? Let's say I had calcium carbonate. This is the formula for calcium carbonate. Same thing. I'm going to look at the negative ion here. Carbonates, hey, it's typically insoluble. I wonder if there's any exceptions. Does calcium fall into any of these trump cards? Calcium's not nitrate. It's not acetate. It's not ammonium. And calcium is not an alkali metal, okay? And when I come in here and I check my textbook and I look up carbonates, okay, calcium is not one of the exceptions, okay? So this is what we'd call an insoluble, which means if we put it in water, it would not dissolve, okay? So if I did a particulate diagram of calcium carbonate in a beaker of water, okay, the whole compound would be together. It would not split up into its positive and negative ions because it's insoluble. Okay, so the things that do split up into their ions are things that are soluble. And if I stuck a conductivity meter into some sodium carbonate, it would conduct electricity. Okay, and if I did the same thing for the calcium carbonate, it would not, because there's no mobile ions, okay, in this solution, where there's plenty of mobile ions here. Okay, let's try another set of compounds to see if you can decide if something's soluble in water or insoluble in water. Okay, let's kind of do this one. We're going to go silver chloride. Okay, now chlorides typically are soluble in water, but there are some exceptions. Okay, and the exceptions are silver, mercury, and lead. And once again, you can find them kind of like on this list right here. So this is an insoluble, even though chlorides are usually soluble in water, there were some exceptions, and silver is one of those exceptions. So if I had a particulate diagram of this, there would be no ions. It would just be a whole bunch of silver chloride molecules that are always together. Okay. Now, if I came in here and did silver nitrate, I look up the nitrate, okay, well, it's one of the trump cards, okay? This means that it's always soluble. There are no exceptions to the trump cards, okay? So if I have a nitrate, it doesn't matter what I pair it with, it's always going to be soluble. And since it's soluble, it's going to split up into its ions. So you're going to have some silver ions, and then you're going to have a nitrate ion, and then you're going to have a silver ion, and then you're going to have a nitrate ion. And they're just all mixed up, okay? So we got a whole bunch of mobile ions, okay, when these ionic compounds actually dissolve in water, okay? Conductivity meter here, it does conduct electricity. Conductivity meter here, it would not conduct electricity according to our solubility rules. So I hope that helped you understand trying to figure out if something is soluble or not. Really, it comes down to memorizing some solubility rules that your instructor gives you. I have my set that I work with my students with. I'm sure your instructor is going to have their set. It's probably going to match up with whatever textbook that you're using in that particular class. If this has been helpful, please like, subscribe, and add a comment.